Hey everyone, welcome to my channel. I'm Venkatesh.Sarivisetty, a cloud DevOps expert, and today I'm diving into the fascinating world of machine learning models. So, machine learning is transforming industries from self-driving cars to fraud detection and even predicting customer behavior. But how do these models actually work? And how can you build one even if you are just starting out? So, in this video, I'll break it down step by step in the simplest way possible. By the end, you'll understand different types of ML models and how they learn and even how to train, deploy, and integrate them into real world applications. So if you are ready to master machine learning the easy way, hit like and share, subscribe button, and let's get started. So first, machine learning models. First of all, uh, here let's discuss about what is machine learning model. Okay. So when you say model, a model is a mathematical representation. Okay. First, let's discuss about model. What is a model? So a model is a mathematical representation. Mathematical representation. Okay. That learns from data to make predictions and decisions. So technically, a model is to do an action. That means it will try to predict like what is going to happen. That will automatically predict that one step ahead, and also at the same time it will do the decisions also. So it is capable of predictions and decisions. So this is the beauty of the model. So where these models can be applicable and where it can be recommendable to use this one, like, so moreover these models are really going to use in a systems like, suppose if you have any recommendation systems, like if it will recommend you like, what are the online stores, online marketings will have, what is your recommendation for that one. So automatically when you are watching a videos, so you are getting some recommendations. Suppose if you are watching a fun video, you are getting that recommendations automatically, right? So that way, recommendations and fraud detection, and also a beauty of models is self-driving cars. We will discuss about this in detail. So on whole, this machine learning models are segregated into three types. You can see in the left hand side. So three types. What is that? One is, so there are three types of machine learning models. One is supervised learning. Let's discuss about this supervised learning. And also you can see in the bracket, I kept it as a labeled data, what it means. Okay. So let's discuss about the supervised learning. Next, we can go for the second and third concept of it. So the definition of the supervised learning is a model learn from the labeled data. That means you have an input and you are expecting a output. So on whole, it is a pair of input and output. Simple. For example, you are asking an input. Okay, you can detect it like whether you are asking a question like whether this is a spam email or a not spam email. It will tell you the answer. And you are asking a question, predict the house prices. So these are the different types of examples I'm telling. Okay, so it will go and predict it. What is the house prices depends upon the different categories and characteristics it will take into the consideration, and then it will provide you the exact result for you. And also sorry, there are few common algorithms will be there for the supervised learning. Okay, so that I will cover. Just I will show you here what are the different types of algorithms. Like if you want to achieve this supervised learning process, we need a algorithm to implement this model. Okay, so when it comes into the algorithms, there are more frequently used algorithms there in the modeling. That is, first one is linear regression. Okay, linear regression. It's just like, as I said, you want to predict the, for example, predicting the continuous values like house prices based on the input features such as size, location, and number of rooms. You can predict that one, like what is the house prices for that one. Okay, that's a input it is expecting, and it is predicting those values. So that's the beauty of this linear regression. The second one is a decision tree. So you can think like why these many algorithms were there. At the end, you will understand why this why and what is the reason for the each regression and how it will help you at time of decision making. Okay. So the next one is decision tree. So decision tree is nothing but it's a tree like model, and it will predict you whether if, for example, I'll tell you one example. You are taking for a loan. Okay, and when you are applying for this loan, this customer will get it has to be go for a different various of verifications, right? Various variations of verifications, like whether you have any disputes, whether you have any extra credit cards, whether you have any debts in your account. So these things will all come under your decision trees. So it will calculate and it will predict whether the person is eligible to take a loan for this applicant. So for this type of designs, the team will look for the decision trees algorithms. The third one, random forest. What it means? It's a collection of decision trees again, which will improve the uh, prediction accuracy in the application, like a customer churn prediction. So it's a collection of all the decision trees. So it's moreover a collection of decision trees. And the last one is about the neural networks. Neural networks. Neural networks is it's mainly used for the complex projects. What is complex projects such as image recognition and NLP, natural language processing. Okay, so the first one is the image recognition. The second one is NLP, natural language processing. Example, like you have a Siri, okay, in voice assistants, right? You know about Siri and the Google assistants, how these are all working. It's a natural language processing. When you ask anything and it is responding to your input. So for that, image recognition and natural language processing, we use neural networking algorithms. So on whole, I just want to repeat these algorithms again. So linear regression used for predicting the continuous values like house prices based on the input features, such as the size, location, and number of rooms. And decision tree is like a tree-like model used for the classification task, like predicting whether a loan applicant will default or having any, I told you, right, extra, etc., etc., to uphold that customer to take the loan, or you can stop it. So different types of variety of matchings it will do, right? So those and all will come under the decision tree. A collection of a decision trees which will improve the prediction accuracy. That will becomes under the random forest. And neural networks is for the complex projects such as image recognition and the natural language processing used for the Siri and the Google assistants. So next, we will go into there is a second concept called unsupervised learnings. Okay, unsupervised learnings. What is a unsupervised learning? So, as I said in the beginning, about the supervised learnings or the labeled data, but this is unlabeled data. What is this difference between this? I'll tell you a small example. Customer segmentation. Like when you have a grouping customers based on the purchasing behavior. Okay, so people will purchase different types of products, and we can group those customers as a one group, A group, and B group will the set of another group. So this type of different types of segmentations will get created. Okay, and on top of that one, we can apply some more algorithms for this unsupervised learning to betterment, to model, and find the patterns from this unlabeled data. Okay, so that is the unsupervised learning, and what are the algorithms are going to implement for this one is like first one is K, K means clustering. So this concept is called as a clustering. Okay, clustering process. As we have a regression in the supervised learning, this clustering process we call it as a clustering regression. So here we have a two types of algorithms. One is a K-means clustering. So K-means clustering is like technically it's used for the market segmentation where business group customers based on shopping habits. As you know, if you take an example, if you go to Amazon or any online marketing, you can select for a set of you want to buy an Apple laptop, or if you want to buy for Apple phone, so you will select it, right? After that one, what will happen, the set of users who are trying to buy this type of laptops or mobiles, that will be grouped. Okay, so like this, the K means clustering will do the different types of habits who are having like who purchase this type of laptops, who purchase this type of mobiles. So they will make this as a clustering mode and keep those shopping habits as a separate clusters. Okay, then on top of that clusters, we can apply the models, different types of the models. And the second one I said, right? The second one is hierarch hierarchical clustering. This means like you will prepare um, a cluster by using the K-means clustering. You know there is a first cluster which is having a group cluster, B group cluster, C group cluster. You are separating those set of clusters, and you will build a hierarchy. Okay, and you will build a hierarchy of the clusters. Okay, the hierarchical cluster will build a hierarchy of the clusters, which will useful in the organizing a documents. Okay, you can organize some documents, and at the same time, or mainly for the DNS sequencing also. Okay, DNA sequencing. This I will explain you at the end about what is this. This is some advanced step for this unsupervised learning. Most probably, what are all the models which we are running, which we are dealing with the day-to-day things will mostly on the supervised learning. Okay, if you go into that next learning, right, that is called that's the most advanced learning process, that we call it as a reinforcement learning. Okay, so what is reinforcement learning? Okay, so this is the definition of this one. What we are going to do here, just a second. So the reinforcement model is The model learns by interacting with the environment. So it's very hard to digest, right? But the model which will interact with the environment and receiving rewards. So it's not about inputs, outputs, or it's not about clustering. Okay. No regression, no clustering. Okay, nothing. So it's completely depend upon the environment and receiving rewards. So the examples for this here is self-driving cars. Self-driving cars, right? It will navigate the roads based on the sensor inputs and the past experiences, which will already took into his consideration, like how to detect the roads, how to detect the bumps and the speed breakers. So everything will be like it's like with the environment, it already digest it and it already rewarded itself as a to learn that model. And also like right now in nowadays we are seeing that AI playing games like chess. So AI playing games like a chess, and there are different types of models, algorithms installed or involved in that one also. That is little advanced, like a deep minds algorithm train themselves through trial and error to outperform the human players. So that is literally a starting phase of challenging AI with a human to play the chess. So that's a little advanced which is going around for now. And here also we have algorithms which we are using for reinforcement. That is like you learning. Okay. This is like a technique where an agent learns and best actions based on the past rewards used in the robotics. As I said, like it will take that considerations, no, as I said, like past experiences for that different types of actions which will took for this action respect to uh, rewards, and it will use in the robotics. And also deep DQN is there, the deep Q networking, little advanced networking, DQN, and it is like a combination of a deep learning with Q learning. Deep learning is something we are using for a auto um, game AI and robotics. Mostly we are using this deep Q networking only. And also the main point here is like the policy gradient methods, which is used in the real-time decision making, such as the stock market prices and stock market bots also. We can manage using this the reinforced learning. Okay, this is about three types of learnings we have. One is supervised, second one is unsupervised, third one is reinforcement. So these are the basics of training your models using the different types of algorithms. Okay, for now, maybe in future they will add some more things, but for now we have this type of learning models. Next, I'll take you to the how you can create a machine learning model, how it is happening. Okay, as I said about the different types of learnings, algorithms, and all, right, how it is going to happen. So as I said in my previous video about the ML operations, how that process is happening, right? It's a simple like first of all, for machine learning, right, the main core is required for this like a data collection. Okay, we need a data collection. Why? Because without a history of data, even algorithm cannot able to provide you the proper, actual, and exact response what you are looking for. So we need to gather the relevant data, like for example, customer purchase history for sales forecasting, and we need to gather the history of data of the different types of diabetic and non-diabetic patients to train your models. And once you collected the data, next we need to do data processing. So we need to clean the junk and prepare the data, and we can handle missing values and normalize the numerical features. So those things will be handled here, data pre-processing. And next, we need to select the model, which model will be appropriate for your respective requirement. Okay, this is the interesting part. We need to choose the model selection. So choose the algorithms, like for example, if you are going with a linear algorithm, linear regression mode, like you can have input and you are getting that output, or else you can go with the decision tree that you have your like for example, you have an input and you need a different amount, different types of and different hierarchy of those information from the respective input pins. You can go with the decision tree making algorithms, and these are the different types of selections you can do under the model selection. Okay, so mainly linear regression for the continuous prediction and decision trees for the classification. You can have a classification like from the for example I said, right, if you want to take a loan, that user will be classified at the different types layers, like whether this person is having any negative data, credit dispute data, credit bonds data, check bonds data. So these things are not will be validated before taking a decision. And then we need to train the model. Okay, so train the model using the split data into the training and testing sets if they fit the model for the training set. So we have to provide that number of data to that model. It will train accordingly. And then we have next step is model evaluation. So it will measure accuracy and performance. Okay, it will use the metrics like accuracy, precision, recall, and F1 score to evaluate your model. So finally, it will tell you that accuracy percentage also. It will reach point values, 1 point values. So based upon that, you will estimate your model evaluation score here. And then the final one is the deployment. So, so finally, when you build this one, you can deploy using your APIs or the cloud platform, converting this model into an API or integrate into your application. So this is the a step-by-step process of creating a machine learning model. Next, so the real world examples I just want to tell you to make you understanding and stick the data in your mind. As I said, like first of all, if you have a problem, like if you want to predict the house prices, just take this as a small example. So example is like you want to predict house prices. Okay, this is your problem. So what are the steps we need to take for this one? First, we need to collect the data. So collect the past house sale data, including the features like a square footage, number of rooms, and location. And the second step is processing the data. So we need to process the data, which is some missing values, and normalize the data to maintain the consistency. And we will use linear regression because this is a input-output fashion to train the model and generate the price predictions. The fourth step is evaluated with the R squared value and mean squared value to assess the model's accuracy and error magnitude. Because these values, like the mean squared errors and the R squared values, these are the mathematical steps we will follow in linear regression algorithms to assess the model's accuracy. Okay, and the errors to provide the better reliable predictions. Finally, we will deploy this API using any tool, like you can use your Flask, you can use your Node.js and allow the real-time price estimation for your new inputs. So these are the steps we need to consider for deploying your application, deploying your model to the deploying to the real world. Okay, so these are the different types of steps. Next is, and for deploying these things, what are the tools we need to use for is like here I just need to consider First one is TensorFlow. So same thing for a Docker, Kubernetes, different tools we have it for the DevOps. For the ML, we need to have a TensorFlow or a PyTorch to train the deep learning models. And for traditional machine learning models, we can go for the scikit-learn. This is one more module we can use for that traditional models. And deployment process, we can have Docker and Kubernetes. Anything, you can use your on-prem or K8s cloud. Fourth one is you can use your cloud services like AWS, Azure, or GCP. Okay. So the example workflow here is like if you want to for base mission for this one, that before deploying into before creating a deployment model for that, first you need to have a tool. We call it as a Jupyter notebook. Okay, this is a tool which will train your model. Okay, it will train your model using the data set we are providing. Data set is nothing but your input. Okay, so the naming is different, but the core is like with the input. So that will convert that model into an API using as we are using a Flask, right? The Flask, it will convert. Flask is one of the Python module to create one API for you. Okay, and finally deploy this API using a Docker and host it into your anything AWS or it in your on-premises. Okay, this is the process of deploying of the model, and you can have your new base mission to make yourself to run that workflow to train your model n number of times. So finally, I just want to summarize this one, like what we have discussed, so that we'll come to a conclusion of that. So summarizing, like as you know, machine learning models will help to make a predictions based on the data. On whole, we need a data. Data is your key player here. Okay, so based upon the data only, a machine learning algorithms will run and it will do prediction, detection, or finding that inputs output. Everything will be happen on top of your data only. Okay, and different types of learnings, as I said, like supervised learning we have, unsupervised learning we have, reinforced learning. This depends upon your development of models and what type of requirement we have, what type of problems we have. Based on that, we can select your learning process. And the key steps, as I said, for like we have to data collection, data pre-processing, and model training, evaluation, and deployment. So these are the ML model pipelines. Okay, ML model pipeline, like we have it for the DevOps pipeline, we'll have for the ML models pipeline. So finally, understand the different ML models enables better decision making in business and technology. Okay, so understand the data is your essence of your machine learning. Okay, next, how much of data we are providing for um, training your model, that much the data will get the accurate message. So the next step is try to, it's an action item for you guys, like try building an ML model using Python, Flask, and experiment with the different data sets on the Kaggle. So Kaggle is a different type of a data set management, for example, if you want a handwriting recognition. So these are the different types of examples we can make use of it. We can get it in Google also. And finally, learn about machine learning operations for managing and deploying ML models efficiently using CI/CD pipelines. For about this machine learning operations, I have recorded a video like what is machine learning operation, MLOps, and how it is going to help you to grow next level to the DevOps and to understand what is happening around the MLOps. So just go through that one. I will tag that recording for you guys also this one. And finally, it's for you. Just like, share, and subscribe to my channel if you watch, if you like this content. And thank you for your support. Keep supporting for this type of videos. Thanks for watching. See you.